8.5 is motion problems. So to solve these problems, we're going to solve problems involving uniform motion. And when I talk about motion, we're talking about like distance and rate. And our big thing that we want to remember with this is a key concept is distance equals rate times time. But we can, and that's always going to be denoted by d equals RT, which we can write that in many different ways. R is equal to distance divided by time. That's how we get our rate. So a question like how far will you travel at 60 miles per hour for 5 hours? So if you went 60 miles per hour for 5 hours, how far will you travel? So I have my rate, which is 60, and I have my time, which is 5. So I'm going to multiply those two together to get my distance. And so 300 equals my miles. So let's look at another example. A train leaves Rye, traveling east 80 kilometers per hour. An hour later, another train leaves Rye on a parallel track at 120 kilometers per hour. How far from Rye will the trains meet? So I'm going to make a table here to do this. Again, we understand the problem when we do our plan. So I have my first train, which I'm going to call the slow train, because it's going a little bit slower. And I'm also going to type up distance. I'm going to make a little bit of a table. Rate. And time. Because those are the three pieces that we need for motion. Then I have the fast train. And that's going 120 kilometers per hour. Now we don't know the distance, but we know that they're on parallel tracks. And we want to know what distance they'll go, that the two distances will be equal. We want to know at what point will their two distances be equal from each other. We know the rate. So there are their rates. And we want to know how long it will take. So the slow train left an hour earlier than the fast train. So let's make the fast train be T. So the fast train gets the time. So the slower train actually gets the time plus 1 because the time it took plus an hour earlier. So now I know that I want to set both equations equal to D. Well, my slow train equation is D is equal to 80 times T plus 1. And my fast train is D is equal to 120 times T. Now notice that they're both equal to D, so I can set the two equations equal to each other. Because I can plug in, just as what we have been doing, I'm going to plug in this piece right here for my D, because that's what D is equal to. So to do that, I have 80 times T plus 1 is equal to 120T. 80T plus 80 is equal to 120T. Subtract 80T from both sides. I get 80 is equal to 40T. Divide by 40, and 2 is equal to T. So I know after 2 hours they'll meet. But that's not the answer to my problem. My problem is how far from the Rye will they meet. So I'm going to plug 2 hours back into. So D is equal to 120 times 2. D is equal to 240. So after 240 kilometers, and I'm going to use the same units that I have right there. So 240 kilometers is where they'll meet. Let's try another one. A motorboat took 3 hours to make it downstream, trip with a current of 6 kilometers per hour. The return trip against the same current took 5 hours. Find the speed of the boat in still water. So I know that I've gone downstream, and I know that then my return is going upstream. So my two pieces will be downstream and upstream. Again, this is another motion problem, so I'm going to have my distance, my rate, my time. I must have gone the same distance, and I know the downstream trip took me 3 hours and the upstream trip took me 5 hours. Now when I'm going downstream, I'm going with the current, so my rate plus my 6 miles per hour is going to get me how fast I'm going downstream. 6 kilometers per hour. But then when I could return, I'm going against the current, so I'm going to have to subtract 6 miles per hour because the current holds the boat back. So again, I can write two equations. I have D is equal to my rate plus 6 times 3, or D is equal to the rate minus 6 times 5. Because they're going to have the same rate, it's just whether it's going upstream or downstream. So, and they'll have the same distance. So now I can set those two distances equal to each other. And I end up with, I'm going to actually distribute that 3. 3r plus 18 is equal to 5r minus 30. So I'm going to minus 3r and I'm going to add 30. 30 minus 3r. 2r is equal to 48. Divide by 2, and 24 is equal to my r. So that is that my rate in still water is 24 kilometers per hour. Okay, next one. Two cars leave town at the same time, going in opposite directions. One of them travels 60 miles an hour, and one of them 30 miles an hour. How many hours will they be when they're 100? How many hours will it be when they're 150 miles apart? So I kind of like to draw this out. That I'm going to put little boxes for my cars. I have a car here and a car here. And I want to know when this distance right here will be 150. So I'm going to draw my diagram again. My diagram, I'm going to have the slow car and the fast car. And we got distance, rate, and time. And again, I have my rate. So the slow car is going 30 miles per hour. The fast car is going 60. It will be at the same time, because they're at the same time they're going to be how far apart. So the distance of the slow car and the distance of the fast car. So I want to know when, and so this is just going to be, distance is going to be distance of slow car I want to know when the distance of the slow car, I'm going to say distance of slow plus distance of fast is equal to 150. Well, distance is equal to rate times time. So the distance of the slow car is just equal to 30 times t, which is 30t. And the distance of the fast car is equal to 60 times t, so plus 60t is equal to 150. So that is that 90t is equal to 150. It's a 5, not an 8. And if I go and divide, I get t is equal to 5/3. Or that is really 1 2/3 hours. So, or 1 2/3 hours. So after an hour and 2/3 of an hour, they will be 150 miles apart. Alright, so here's one for you to try. This one's like the motorboat one, so go back to your motorboat problem if you're curious or if you don't quite understand how to do it. See if you can rewatch the motorboat one to try it out.